Okay, so here's the basic idea with transformations. Okay. Okay, so all the transformations are going to be kind of built into one of these letters here. So I'll start with, there's A, F of Bx minus H plus K. Okay, and you're going to be representing each of these with different numbers, but you'll do it one at a time.
Okay.
Okay. So the A is going to take the function and it's going to stretch. Well, it's going to be a vertical stretch or shrink. Okay. The B is going to be horizontal shrink or stretch. The H is going to shift the graph left or right. And then the K is going to shift the graph up and down.
Okay.
But this is just a general formula, right? You're going to adapt this to the specific function that we're dealing with. So the first is quadratics. In quadratic function, you have a parent graph, which is y equals x squared. This is the parent.
Okay.
And you know what this looks like. You can enter this into Desmos, and this is kind of like the starting point. And then if we change the A, if we change the B, if we change the H, or if we add the K, it's going to take this shape and it's going to do all sorts of things with it. It's either going to be stretching it, widening it, moving it up or down, depending on which part of these you change.
Okay.
So I'll do one or two, but then you're going to have to, do the rest. Okay. So let's say I want to just play with this H right here.
Okay.
Everything else I'm going to leave alone. Okay. So I'm just going to insert that H into this X. So this is my function here. So my F of So let's say I want to just change that to a different number. Okay. So I'm going to add it. Let me make it x minus 2 squared. And you would enter this into Desmos. You know it's going to be shifting left or right because it's dealing with that H there. And if you put in the Desmos, it's going to be here. So what would you conclude? This H is going to do what to the graph?
I think.
What's it going to do to this parent graph?
I'm trying to remember what you said. I think you said.
Or I think you just tell by looking at the graph, right? How is?
Oh, I was gonna say move it left or right.
Yeah. Which direction?
Right.
Yeah.
Over 2 units or
Two.
something like that.
2 units. Yeah.
So, Mr. Yang, we're not using no type of numbers, right? For this, we're not trying to find no numbers, right?
Yeah. You're going to be creating your own value, putting the decimals, and then describing what is changing about the parent function.
So, where do we get the numbers from, or do we just find them on our own?
Yeah. I would just use small numbers.
Oh, that makes sense now. So just use random small numbers.
Use random small numbers, and then just describe what happens to it. What happens to this graph?
Oh.
So let's just do one more. Which one do you wanna explore?
Let me go to bed. BX, because I don't get that one at all.
Okay. So the f of bx. Okay. What number do you want to choose for b?
3.
3. Okay. So you would just put 3 in 3x in place of this x here. So what that parentheses means is that you have to put these values inside the x, or inside the x with the squared outside. So it's going to be 3x.
Okay. So when we graph it for Desmos, what do we put?
Just say y equals parentheses 3x quantity squared.
Oh, so don't use the f of x, just use the y.
Yeah. Just use the y. You can just say y equals.
Okay.
And then it's going to be really narrow.
I think you said B is gonna.
Yeah, so it's going to
A horizontal stretch, or.
Yeah, this is going to shrink it horizontally. Because, right, if it was like 1/3 or 1/4, it's going to make it really wide, but it's going to kind of shrink it horizontally. So we say shrink. And there are rules here that you can check out, but it's going to shrink horizontally by a factor of 1/3. Everything is kind of opposite. That b is a little bit strange. It's going to always be the opposite.
Okay.
And then you'll do the same thing. Pick a value for k and observe what happens. Pick a value for a, observe what happens. And then I think for the 5th graph, you're going to have to put in a, b, h, and k all into the same function, and then describe all the things that are changing to this graph.
And how would that look if I was to put A, B, H, and K all into one?
That's fine. Well, choose numbers. What number do you want to pick for A?
No, not like just example, like how would I where would I put A, like in the same exact spots it looks now, in like.
Yeah, just replace these with numbers.
So we still put the F right there next to A, or no?
Well, no. Well, the F is no longer there. Now you're dealing with this particular function.
Okay. And then you take, so don't worry about the f of x, just use
That's
the
right.
A.
The f of x is a general formula, but we're dealing with a quadratic. So your A, B, H, and K is all going to be built on involving this x squared.
Okay, and that x next to B, don't worry about that neither, right?
Yeah, don't worry about this.
Okay, that makes sense. And then with the absolute, this is my last question.
Well, let's do an example. What do you think this will look like if I put A, B? So let's pick numbers here. What do you want to choose for A?
I'll go with 2.
Okay. What do you want to choose for B?
I'm gonna say 4.
H?
Probably Probably 3.
Okay, and then k.
I'm gonna do 6.
Okay, so where would all these go for this function that you want to build?
It'll be y, yeah, and then your a will go first.
Mm-hmm. Parentheses.
Yeah, parentheses, and then your b will go. Yeah, I put 4 for that, so 4 going to parentheses.
4x.
4x, okay, and then it'll be minus 3
Mm-hmm.
plus 6.
Yeah, and then you would just you'll graph it, and you would describe what's all happening. Stretch, movement, left, right, stretch, shrink, all that.
Okay.
Okay, so now for the absolute value function. We have a parent graph. Y is equal to absolute value of x, which looks like this. You enter this into Desmos. You just type in ABS. It'll recognize that it's talking about absolute value. Or I think there are some icons you pick for absolute value. So same thing here. You're just going to put A, B, H, and K around. So, and then you would do the same thing. But let's do a graph with A, B, H, and K all involved in here. What do you think that will look like? So pick another set of A, B, H, and K.
For A, I want to use 6 again. No. And then for B, I probably want to use 5. And then H, I want to use 2. And then for K, I want to use, I'm going to go with 7.
Okay, so how do you think this will look if you want to put them all within this type of function?
It'll be I mean 6. And it'd be 5x minus 2 plus 7.
Yeah. But, you would do each of the graphs for each of the different transformations that the rubric asks you to do. So all in all, I should be doing like 10 graphs or so.
Okay, that value is tricking me out. So for that what we just did, we do that for for all 5 of them, right?
Yeah. So this one will be the first one. This one will be the second one, and then you'll do one with just a K involved. You'll do one with just the A involved, and then you will do one where A, B, H, and K are all in the same, are all impacting the same, the parent graph.
Okay, so for each 5 of them, both supposed to have an absolute value function and a quadratic function, right?
Yeah, so there's going to be 5 for quadratics, and then there's going to be 5 for absolute value functions. You're not going to mix them together. You know what I'm saying?
So the absolute value, that's how we set it up for each and every one of them.
Yes, yes.
Okay, it doesn't change, right? Like the quadratic, how we play with different numbers, right?
No, I mean, you see how all these functions are related because they all are x. They're all basically x squared. Just like how all these functions that you're building for absolute value are all going to be related. They're all going to be falling into the same family. So they're all going to look like a V. It's just maybe the V is differently, maybe wider or shifted left, right, or up, down, but it's all kind of based off of the same starting point.
Okay. So if we was not 5, but for the absolute value, if we was doing 1, which replace f of x with k, we would just do k for the absolute value situation.
Yeah. So how would you do one with just k involved?
It would be y equals whatever number I choose to put in that little parenthesis, right? No, hold on. Yeah, whatever number I choose to put in where x is, and it'll be plus.
No. This will remain as x.
Oh.
Otherwise, if you put number in here, then you lose the function, right?
Okay, so just be y.
All these functions have x's in them. You're not going to replace them with numbers, because if you place them with numbers, it's going to be just 1 point. You need the x here, so it'll actually graph out a function for you.
Oh, okay. So it'll be y equals x, them 2 little bars, and then plus whatever number I want with k.
There you go. Yeah, you're only replacing a, b, h, and k with numbers. The x is you're not gonna make that a number. This has to stay as a variable.
Okay, well that makes sense. I was kind of confused. I was like, do we do that for everyone or just that far? Okay, that makes sense.
Okay, so hopefully that will help.
Yeah, it does.
Okay, so give me 1 second here.